Java. Hi guys, I just want to introduce the big process in Java which has been automatically built in it. And unlikely in C, we were having destructor and constructor, but in a Java, you know that this process has been already taken care by the JVM, right? So I'll just introduce what is the garbage collection here, and I'll show the live example. So first of all, if we are to look into the garbage collection is an automatic process of looking at heap memory, identifying which objects are used and which are not, and deleting the unused object is the garbage collection. And if you think about, oh, what is used and unused object? An used object or reference object means that some part of your program is still maintains a pointer to that object is called the used object. And another one is unused object, where the unused object is just means unreferenced object is no longer referenced by any part of your program. So the memory used of an unreferenced object can be reclaimed and garbage collected. So this is the small introduction of garbage collection. Now we will see that how we can go by one to the different slides. What is the actually a JVM, right? So I just want to give you the small introduction about the JVM architecture. My main object is to show you where the heap comes into picture in the JVM architecture. So if you see, this is the JVM architecture, where the class files or class loader is first. We have a different of class loader. I'll make a different video and I'll explain what are the class loaders and how we can override a class loader. But here you just see this in the runtime data access. There are a method area, heap, Java threads, program counter and registers, and native internal threads. I am just talking about right now heap. We will take the other parts later on in different videos, but just see, this is the heap and this is what we are talking about for the garbage collection. So whenever the memory is initialized for Java, for your program, it is all initialized in Java heap. So this is the part of Java heap. Okay, so we'll talk about this only, how the object are being initialized, where the object are initialized, and how those are reclaimed. Okay, so if you see the this video, this will explain how actually the garbage collection worked, right? The object is deleted when it is not reachable anymore. When we say reachable, means it is not referenced by any of the pointers in whole program or within that JVM itself. The basic idea of reachability analysis is to trace the object or reachable by a chain of reference from the root object. The root is called GC root, and the path from the root is certain object is called the reference chain. If an object cannot be reachable from any GC root, it will be considered as a garbage and the storage will be released. So this is, if you see this here, we are talking about the GC root. This is GC root is pointing to the object this, and then this object is pointing to two other object. So this is called the used object, because GC root is still pointing those objects. So this object cannot be reclaimed, or this object cannot be garbage collected. But if you see another side where the GC root is null, it is not pointing to anywhere, and those only three objects are free. So this is the chain. When the garbage collection looks, this chain is now the garbage collection is very sure that these three objects can be reclaimed and garbage collected. So this is how the garbage collection looks. Now next, if you see the next slide, this process I will explain, but let's see. This is a simple program where I just want to explain how actually the garbage collection works. We all know that in Java we cannot force JVM to run the garbage collection. A garbage collection runs by JVM, and it is a daemon thread. It's always run in the background. We will not come to know what time it runs, but yes, we can definitely suggest to JVM when the garbage collection can be run on your object. How we come to know, actually, this is the finalize method. The finalize method is actually defined in java.lang.object class, and I just override it from there and have a small system.out.println to show that whenever it is called, and this is for the current object. I have this make the program, and where I created one object, and that object I set as a null. So whenever you set as a null object, it means that the object is no more um, reachable, and it is ready for garbage collection, right? So that's where I decided this object to be reclaimed. And how we can suggest JVM, right? We can suggest the JVM by two ways, but before suggesting JVM, I just want to show you. If you see this program, right, if I run, is a simple program, and this program just come out the main method ended, right? It never calls finalize method. How we can suggest JVM to call the finalize method on particular object? The finalize method, just remember, it is being called for each object. Whenever the object is being reclaimed, it is called on that object. Okay, so how we can suggest? There are two ways to suggest JVM for the object for garbage collection. One is system.gc and another one is runtime.getRuntime.gc. So even the system.gc also called the runtime.getRuntimeGC. So any one of them you can use. So I will just use the runtime.getRuntimeGC. So in this, if you see this, if I run now, right, my the object is being reclaimed, right? Whatever I defined as a g1 equal to null, that object is being reclaimed by suggesting to JVM from the calling gc method, right? And then the gc method, and this shows this print out what we say object garbage collected on console, right? It shows that this object is g1 is garbage collected. So this was a just simple program to show you how the actually garbage collection worked. Thank you. Because our finalize method is called, and I just given the this to that so that I know that which object is being garbage collected, right? So if you see the Java, this object with the hash code has been garbage collected. This is just a simple program how we can suggest to JVM to collect to garbage collect of an object, right? So here I want to explain to you how actually this all things works, right? There is a three things in Java mainly on that things is work. One is called the marking, then is called the sweeping, and then is called the compacting. Okay, so here all the things process I'll explain one by one. Number one, marking, right? What is a marking? The first step in the process is called marking. This is where the garbage collector identify which piece of memory are in use and which are not, right? So this is when the garbage collection threads or daemon threads goes and check each an object and see that whether the object is being referenced by someone or it is just unused. And if it is unused, then it is marked. So if you see in this one, the top one is before marking, and then second one is, you see the daemon thread scan each object and mark that, oh, this is whatever the yellow in color, they are saying that, oh, these objects can be reclaimed and they are not anywhere reachable in the program, right? So that's where it is marked. They call this step called marking. The next step we have called the normal deletion, we can say sweeping, right? So in this step, what happens? The normal deletion remove unreferenced object, leaving reference object and pointers to free space. So what it does, only it is just whatever in first process they marked, in the second process it deletes those objects or sweep those objects. The third process what is called the deletion and compacting, right? This is what I was talking about. So this is marking, sweeping and compacting. In this process, what the garbage collection thread does, to further improve performance in the addition of deleting unreferenced object, you can also compact remove the remaining reference objects. Why? Moving reference object together, This makes new memory allocation much easier and faster. So in this process, what the thread does, it deletes the object for sure, it sweeps the object, but also it compacts the used space so that we can get the last memory together free, where the object easily can be generated, or they can sit together even if they are large, right? So this is the process, three-step process: marking, sweeping, and compacting. The third, this object, I just want to show you slides that we have a many how this everything is actually work, because it's mainly is the generations, right? So we know that in Java we have a three generation, and I'll explain in next PPT. But in this C, if you see the most why actually the generations, right? So I just want to show you in this video, we have a minor collection and then we have a major collection, right? In Java there are two types of garbage collection happen. One is minor collection happen, and one is a major collection. This is called the full GC. Minor collections happened only on the first generation, called the nursery or the young generation, where the garbage collection happened minor, and the major collection happened in the next generation, called the old generation or tenor generation. We will explain in this video, but here I want to show the why the most of the time whenever the object is being created, all means 90% objects are short-lived, right? That's where, and this minor Java collection only explain those claims only those short-lived objects, and it takes only few milliseconds to collect them. So that is why in Java mostly we have these generations, because young generation is 99%, 90% is being used, and the garbage collection only works in that. Only few times we are using the tenured or old generation, and that is very few time. And in this slide, if you see this also, it explained clearly that this used space is very less and compared to the minor collection, where the young generation come into the picture. Okay, so I will just want to show you this one. This is the hotspot heap structure of before Java 8, right? In Java 8 we know that the permanent space has been separated out and it become a meta space. I will explain this in my next garbage collection video, how it was separated in Java 8 and what is the changes from Java 7 to Java 8. Till Java 7 we were still having the same structure like this what I am showing right now. So we have a three generations here. One is called young generation, then the old generation, and then the permanent generation. So when the young generation further divided into three space called Eden, S survivor 1 and survivor 2. Yeah, S0 or S1, right? All the objects whenever they created in the Eden, or this is called the Eden space or a nursery, where the object is created, and slowly when the garbage collection runs, they move to S0 or S1. And then if they are able to survive in S0 and S1, then they move to the tenor or old generation. And this is where the full garbage collection happened. So I just want to show you the generations, how these generations are working. So we have a young generation. The young generation is where the new objects are allocated and aged. When the young generation fill up, this cause a minor garbage collections. As I explained before, stop the world, right? This is big event happens in the at the time of garbage collection. All minor garbage collections are stop the world. Stop the world events. This means that the application thread are stopped until the operation completes. Minor garbage collection are always stop the world event. So whenever it happened, it stop all your threads, all the threads related to application, and the garbage collection runs, and then later the application thread starts again. We are not able to calculate it because it's just it takes few milliseconds, but yeah, if it is a major application, of course you will notice this one, but in a small application we will not be able to notice at all. The second one is called old generation. The old generation used to store long surviving objects. Typically a threshold is set to the young generation object, and when that age is met, the object gets moved to the old generation. Eventually the old generation needs to be collected. This is called the major garbage collection. Here we have major garbage collection, and sometimes we call the full GC as well. The last generation what I explained in the previous video, the permanent. This permanent generation, right? The permanent generation contains the metadata required by the JVM to describe the classes, methods in the application. We don't run any kind of garbage collection here. This is just defined. But yes, sometimes if you don't define the permanent space properly, sometimes you may get the out of memory error even the permanent generation. I hope that if you like this video, please like and subscribe. And I will come with the next more videos.